So when we say the features of quadratic graphs, we mean its physical features. You're looking at the graph and you're talking about the features that you see. So I've given you a graph over here. Don't worry about the equation. That's not important. You have the picture. I've given you some really big, pretty dots, so they're obvious and you can see where they are. Okay? And we're just going to fill out the requested information. The first one says, where is this quadratic's vertex? And I mean, just look at the picture and tell me the coordinates of the vertex. So I'm actually going to write the word coordinates. This is a thing that is asking for coordinates, x comma y. What are the coordinates of this thing's vertex? Where is it? Good. Dalen? I'm sorry? 3, negative 3. Perfect. I'm going to put a little v in front of it. You don't have to. I just like to do that because it tells me that's the vertex at 3 comma negative 3. Yeah, there's our vertex. You know what? I'll put a little v on the graph. Vertex 3 comma negative 3. The next one's asking for the axis of symmetry. Can I get a volunteer to tell me the axis of symmetry? Sam, what do you got for me? Thank you for saying the x equals. Yeah, x equals 3 is the axis of symmetry. I'll even write it in red because I like to draw my axis of symmetry in red. There you go. X equals 3. Label it on the graph. There we go. Remember, if you don't say the x equals, you're going to end up earning half credit on that question on the test, and I don't want that to happen to anybody. I've said it every single time I've graphed it. I'm hoping that that's kind of sunk in. The y-intercept is a coordinate. And you'll see why I'm writing this in a moment. But the y-intercept is the point where the graph crosses the y-axis. Where does this thing cross the y-axis? At 0 comma 0. Yes. Good. So we're just looking at our graph. The zeros are the places where you cross the x-axis. So I'm going to say that these are coordinates, and they are the x-intercepts. So saying the word zeros is just another way of saying the x-intercepts. Mr. M, why do we call them zeros? Because those are the places where y equals 0. Because when y equals 0, you're on the x-axis. But that's why we call them the zeros. But I would be asking for the coordinates of the two zeros. Well, one of them, Catherine just gave us. One of them actually happens to be the y-intercept as well. It's the origin. So that's going to give me 0 comma 0. But what are the coordinates of the other 0, the other x-intercept? Just making sure we can all do this. I can call on random victims. Lewis? 6 comma 0. Awesome. Thank you. Great. From here on out, on this example, we're going to be using new, quote unquote, new knowledge, new vocabulary maybe, new properties of a graph. It says minimum or maximum value. What I'm going to ask that you do on this and in the homework is circle, first of all, whether or not this thing has a minimum or a maximum. So you just circle the word. And then we will actually write down the value. But just look at the picture. Does it have a minimum value or a maximum value? Shout it out, guys. 2, 3 people spoke. Maybe the problem is either 1, we're not paying attention, or 2, we're not quite sure what it means to have a minimum value or a maximum value. Well, what does the word minimum mean? It means smallest. What does the word maximum mean? It means biggest. What I would like to do is remind you that even though the grid comes to an end, the graph does not. This thing points up forever. Does it have a top then? No, it points up forever. It never has a top, quote unquote. Points up forever. It does not point down forever though, which means this graph has a minimum. It has a bottom. that it never goes below. Since it has a bottom, it never goes below, we say this graph has a minimum. And what is that minimum value? Well, first of all, it is always going to be a y value. So minimums and maximums are always y values. And they are always, for quadratics, always the y value of the vertex. And that doesn't matter if it's a minimum or a maximum. It will always happen at the vertex, because the vertex is either the bottom of a quadratic, like you see here, or the top of a quadratic if it's one of the ones that points down. Cool with that idea? So a minimum is a bottom, a maximum is a top. This graph points up forever. It does not have a maximum. It does have a smallest value, a minimum. And that smallest y value is y equals -3, the y value of the vertex. So now, do you see why I make you say x equals when you're talking about the axis of symmetry? Because y equals is going to be where your minimum or maximum occurs. So x equals the x value of the vertex is the axis of symmetry. Y equals the y value of the vertex is the minimum or maximum value. Cool? Okay. Domain. What does it mean to say domain? Now you've probably talked about domain in Algebra 1 and range in Algebra 1. Do you remember it? Well, there's a good chance you don't. I know that was a long time ago. So I'm just going to, appreciate you, Liz, but I'm just going to fill it out. That way it makes the notes, both the physical ones you have and the video on YouTube. The domain is all x values that the graph, and I'm going to use the term in quotes, covers. So if you could take this graph and grab it from the top and the bottom and smash it flat onto the x-axis, what x values does it cover up? Sam? So what Sam said was negative infinity and positive infinity, but in words, that means everything, right? This graph, if you smashed it flat on the x-axis, would cover the entire x-axis. So all real numbers. The way we are going to describe spans of numbers in this course, instead of saying all real numbers, instead of saying words, or instead of using inequality symbols, we're no longer going to use inequality symbols. We're going to describe spans of numbers using something called interval notation. Interval notation sometimes looks like a coordinate, and that is why I wrote those are coordinates. But domain, range, increasing and decreasing are intervals, a span of values. And these are the x values. We cover everything to the far left, which is where negative infinity can be found, to the far right, which is where positive infinity can be found. So let's talk about that for a moment. This parabola points up forever, but it also points left forever and right forever. Numbers never stop. So when you say to the left forever, you're going -1, -2, -3, -1,000,000, -10 billion, -300 quadrillion, -infinity as you continue to go to the left. And as you go to the far right, the same thing's going to happen. 1, 2, 3, 10, 100, 1,000, 10,000, 1,000,000, 10 million, 10 quadrillion, so on and so forth to the far right towards the numbers positive infinity, the idea of positive infinity. So the way we list every single number is saying negative infinity to positive infinity. When you write your interval notations, they always go from the left to the right. I mean, in English, we read from left to right, correct? On graphs, you read them from left to right as well. So we read the number line from left to right. So the left thing is the small thing. Negative infinity is the smallest thing you could imagine. Positive infinity is the biggest thing you can imagine. So it goes from small to big. Mr. M, What do the parentheses represent? The parentheses represent a number that you are not going to hit. You see, infinity is not a number. It's a goal. It's an idea. You can never hit that number. Therefore, you put a parenthesis on it. That is singular for parentheses. You put a single parenthesis on every infinity, positive or negative, because you can't actually reach those values. Okay, Graydon, what's happening?
I'm so scared.
Scared of what?
We went from graphing 3-3 to infinity.
Okay, the range is all of the y values that the graph covers. That means if you could grab this thing from the left and the right and smash it flat against the y-axis, what y values does it cover? Does it cover all of them again? No. How come? Because this graph has a minimum, it does not shoot down forever. It has a smallest, and this says y values, a smallest y value. What is that smallest y value that this graph hits? -3. But it shoots up forever, correct? So it goes from -3 to positive infinity. I just told you that all infinities get parentheses on them because you can't hit them. But does the graph actually hit the number y equals -3? Does it actually happen there? Well, there's a dot there. The vertex occurs at 3, -3. So does the graph hit the number y equals -3? It absolutely does. It does. It hits y equals -3 when x equals 3. So because it hits that number, we don't put a parenthesis on it. Instead, we put a bracket. Bracket means I hit that number. Parenthesis means I try to get there. Say it again. Bracket means I hit it. Parenthesis means I try to get there. This thing is listed from small to big. -3 to positive infinity. Intervals are always written from small to big. Yes, Lewis? You're always going to put a bracket on the minimum or maximum value that occurs at the vertex, but only when you describe range. Because the domain is always going to be all real numbers. The domain of every quadratic, because they point left and right forever, is the same, all real numbers, -infinity to positive infinity. But the range will never be all real numbers for a quadratic. That means we will always have a bracket in our range. It's either going to be at the minimum, if it has a minimum, or at the maximum, if it has a maximum, which, yes, Lewis, will always occur at the vertex of a quadratic. Okay. Increasing and decreasing, it already says interval. That means span of numbers. So I don't need to write that it's an interval. And this domain and range, I wrote all values that the graph covers. So you understand that this is a span of numbers. It is not a coordinate. Increasing interval, decreasing interval is asking you, where is the graph going down? Where is the graph going up? That's what that means. So the way that I ask my students to understand this, go, okay, remember, first of all, we read from left to right. I want you reading your curves, quote unquote, from left to right. And imagine you're on a roller coaster. There's your roller coaster car. Here's you. Yay! Okay, you're on a roller coaster and you are riding this curve. Right now, what would your car be doing? Rising or falling? Falling. So that means this curve is decreasing right now. And when I say right now, what I mean is on the span of x values, this graph is decreasing or increasing. So when you describe intervals of increasing or decreasing, you're describing this on x values as a span of numbers. Only the x values. We don't care what the y values are. Come on, active panel, catch up with me. I hit undo. What's it doing? It's frozen. There we go. The x values. So let's look back to our dude riding the roller coaster, or gal riding the roller coaster, whatever. Someone's riding a roller coaster. This car is going to be falling. And at some point, it will stop falling and it'll start going up, correct? Where is that point always going to happen when it changes on a quadratic? He says in the middle. Sam, what does that mean? At the vertex. Yeah. The axis of symmetry, the vertex, the middle. Yeah. For a quadratic, this is always where your roller coaster car is going to change. It's either going to change from falling to rising, which you're seeing here, or rising to falling if you have a downwards facing parabola. We are going to describe that using our x's. So for this graph, our car is falling to the left of x equals 3. Can we all see that? At every x value to the left of x equals 3, my car would have been falling. At every x value to the right of x equals 3, my car would have been rising. So at every x value to the left of the number x equals 3, my car is falling, decreasing. When you describe every number to the left of 3, you say negative infinity to 3. This is an interval. So I've already told you, infinities always get parentheses because you can't actually get there. Now the question becomes, though, does this 3 get a parenthesis or a bracket? And let me ask you a question. If the car is sitting right here, and you took a picture of it, and you couldn't see the person, it's not in motion right now, it's a still image, a picture, and there was no person in it, so you couldn't see which way it was facing. Is this car rising, or is this car falling, or is it both, or is it neither? It's neither rising nor falling. So what that means is at the point x equals 3, you cannot describe this graph as increasing. You cannot describe this graph as decreasing because it's the point where you changed. You are instantaneously doing both or neither at the exact same time, which is weird. So because of that, you always put a parenthesis on your increasing or decreasing intervals. Because I can't say at that point, I'm still falling. Because isn't that the instant where you were falling and rising at the exact same time? The one instant in time? So increasing happens everywhere to the right of x equals 3. So we begin at 3 and never stop rising. Notice I didn't give a squat about the y values. I just wanted to know, was the graph going up or going down at that time? And that's how I describe my intervals of increasing, decreasing. There should be some questions in the room, and I would be more than happy to address them. How to do interval notation, why some of these things look the way they do, before I move on to examples where I don't give you the graph. I need to answer some questions. Graydon.
So with a negative slope,
You mean with a negative
infinity?
Negative infinity?
Yeah, so like when it goes like this.
Oh, you mean where a graph that points down?
Yeah.
Okay, yeah.
Would the part like be on top of it again?
Yeah, yeah. Yeah, so if you had to imagine the roller coaster car, it's on, quote unquote, on top of the graph. But otherwise, it would fall, right? Yeah. So, and for that thing, so if you're imagining a downwards facing parabola and you start on the left, your car would automatically be rising until the vertex. So it increases on the left, decreases on the right. I don't need you to memorize that. I need you to just be able to see it and go, oh yeah, look, it's on the left side, if my car was there, I'd be going up, and on the right side of my car was there, I'd be going down. I just need to be able to see those things. But yeah. Any more? Yes, Lewis. Yes, all of this material is on the test. No, I will not put all real numbers. It would say negative infinity to positive infinity. That's good to know. Yeah, no, whatever it looks like on my notes, that's how it always looks on the test. I try to make sure that my notes and my homework look identical to test questions. I don't like surprises in math. I think they're rude, you know. Any more cup? Yes, sir. Why do I put parentheses on the infinity? Because parentheses means I can't get there, but I'm trying to. And since infinity is not an actual number, the graph will never get there, but it'll never stop trying. You know, since numbers never stop, you can always go up one more. There's never quote unquote an end, so you can never reach the actual end. So we always put parentheses or the beginning, negative infinity, because they're at the beginning. You can never actually reach that number, that value, so he gets a parenthesis. But for the range, do the y's stop going down at a specific value? Yeah, they did. And what was that value? -3. And that's why we put a bracket on it. That means, yeah, we stopped at that value and we hit that value. Notice it was the only time I used a bracket up here, was the range. So for quadratics, range will be the only place you see a bracket. Don't let me catch you with a bracket somewhere else on the test. A domain for every quadratic is the same thing. Negative infinity, positive infinity, because they always point left and right. All right. So let's do an example where it's not pre-graphed. The very first job you're going to have is graph it. That's the very first job you're going to have. How do we graph it? Well, you first identify what type of quadratic you're looking at. That's why my goals over there on the board, I think the goal number 1 says determine the quadratic form. And it could be vertex form, it could be standard form, it could be intercept form. We look at this one, you see 2 sets of parentheses. You should immediately identify that as intercept form. You might as well write it. This is intercept form, 2 sets of parentheses. The free information that intercept form gives you is the 2 x-intercepts, also known as the zeros. So this thing is going to cross the x-axis at what makes the inside equal 0. So it's going to happen when x equals -2 and y is 0. That's why we call it a 0, because y is 0. And when x is +6, y is 0. So -2, 0, and 6, 0. There you go. The next thing I've asked you to find is the axis of symmetry. You were already doing this when I had you graphing these things. This is intercept form. It gave me the 2 x-intercepts. Where can I always find the axis of symmetry when I have the x-intercepts, Dalen? Yeah, in the middle between those 2 numbers. So you can either count and see that there's 8 spaces between them. So if you moved by 4 spaces, you would find the axis of symmetry at x equals 2. Or you could use the formula, p plus q divided by 2, just to demonstrate the formula. P plus q divided by 2. So you can see it works. Yeah, it hits x equals 2. Now I'd ask for you to look at the equation. See that it starts with a negative number. And I'm going to ask you, does this thing point up or does it point down? Lots of people can shout it out. Oh yeah, it points down, I agree. If it points down, and I'm gonna do this with my arms, it's too bad this doesn't make it onto YouTube, but I'm holding them down. Does this quadratic, you're looking at my arms, hopefully, the graph that points down, does it have a minimum or a maximum? It has a maximum because it has a top. So I'm gonna go ahead and circle the word max. And now we're going to find what that max value is for the vertex. So first of all, the vertex is a maximum. We know that. I want to know what that max value is. I know it happens somewhere on the axis of symmetry. I know it happens somewhere on the axis of symmetry. So I know that the x value is 2. I wrote 3. I know that the x value is 2. How do I find the y value, which is going to be my maximum value? A few people said it, I'm going to plug it in. I'm going to figure out what happens when I plug in x equals 2. Instead of saying negative 0.25, you guys okay if I say negative 1/4? I think that's easier to deal with. So negative 1/4 of 4 times negative 4. The two, let's see. Oh, I forgot my negative sign in front of my 1/4. The two negative signs would cancel out. And 1/4 of 4 equals 1. So the negative 1/4 and the negative 4 will cancel out, leaving you with the 4. So that vertex happens at 2, 4. Our maximum value is 4. We can now graph this quadratic. There you go. We can now see its domain, its range, its increasing and decreasing intervals. Because all 4 of those things, domain, range, increasing, decreasing, are intervals. They are not coordinates. Domain. This is a quadratic. The domain for every quadratic is exactly the same. Lewis already told us what it is. Lewis, what is it? Negative infinity to positive infinity. Yep. That is going to be the same domain for every single quadratic because they always point forever left and right. Our range. Our range is the y values this thing covers up. You've already told me this graph has a maximum. Can I get a brave volunteer to tell me what they think the range is as an interval? This includes my homies, but Sam, your hand went up first. What do you got for me, sir? Negative infinity to 4. And describe for me, please, parentheses, brackets, what should I write? Perfect. So you see 4, because it was a maximum, was listed second, because we always go from small to big, left to right. We're listing the y values, left to right, sorry, the y values from bottom to top. This graph has no bottom. So it points all the way down to negative infinity, which you can never actually hit, and it crashes all the way up to y equals 4. And yes, it does hit that value y equals 4, and that's why we get a bracket there. For quadratics, there will always be a bracket in the range somewhere. It'll either be at the minimum or the maximum every single time. And these are y values. Y-intercept. Oh, yes, question for me? Yeah. Mm-hmm. Yes, if it's a maximum, the number will always be on the right because it's the quote-unquote biggest. Mm-hmm. And if it's a minimum, the number will be written first because it's the smallest. Yeah, because our intervals are always written from small to big. Yeah. The y-intercept. Okay, well, when you have the graph, normally you could just look. But man, you know what? I drew a crappy graph, didn't I? It's not very good. I'm not allowed to just guess at this y-intercept. I need to be able to calculate this y-intercept somehow. Well, guess what? When you're on the y-axis, you know what x equals. When you're on the y-axis, what does x equal? Lots of people could say it. One person said it. Wow. Lots of people? 0. When you're on the y-axis, x equals 0. So if you want to find a y-intercept, you have to plug in x equals 0. You have to plug in x equals 0 if you would like to know the y-intercept. Don't worry, you'll have a calculator. I do know that the two negatives cancel. And I know that 6 times 2 is 12. What is 1/4 of 12? 3. So my y-intercept is at the coordinates 0, 3. See, my graph was kind of poor. So I'll just do this. And I'll make the dot so big that it covers up our mistakes. Because it's a sketch. We're not artists. But we can tell us using mathematics, we can tell ourselves that, yeah, we crossed this y-axis at y equals 3 when x is 0. So now the last thing we have to list is increasing, decreasing. If you were riding this roller coaster to the left of the axis of symmetry, do you have to draw the roller coaster car every single time? No. I'm doing it because I think it helps. If you were riding this roller coaster right now, would you be going up or down? Up. So to the left of the axis of symmetry, you're increasing. To the right of the axis of symmetry, you are decreasing. Increasing, decreasing is always going to be x values. I'm going to write that again. It's a span of x values. You said we were increasing first to the left of the axis of symmetry. All the numbers to the left of the axis of symmetry. So stretch all the way to the far left, negative infinity. Stop decreasing at the axis of symmetry at x equals 2. But at the value x equals 2, the very, very top of this quadratic, I'm increasing and decreasing at the same time, or doing neither. And because of that, we cannot have a bracket in our increasing and decreasing. It'll always be a parenthesis. And then we begin falling at the value x equals 2. And you never stop falling as you head to the right. Now this blows up students' minds. Mr. McCutcheon, isn't that graph going down to negative infinity? Yeah, it is. But those are y values. And nobody gives a flip about the y values when we're talking about increasing, decreasing. What you're doing is you're describing what's happening when x equals some number. So when you say this, you are describing to me what's happening at every x value to the right of 2. When x is 10, I'm decreasing. When x is 1,000,000, I'm decreasing. When x is 10 quadrillion, I'm decreasing. But you see the x values are increasing forever to the far right, to positive infinity. Are the y values going down? Yeah, but nobody cares. That's happening by saying decreasing. Yeah. Okay, what's up?
I'm pretty sure you just got me saying it, but what does it mean by increasing and decreasing?
Increasing and decreasing describes what the graph is doing on the x values. So when x is, and this right here, this negative infinity to 2 for decreasing, or excuse me, for increasing, that says x is less than 2 if you were going to use inequalities. So it says when x is smaller than 2, my graph is increasing. That means if you were riding this roller coaster to the left of the number x equals 2, this roller coaster was going up. And after x equals 2, the axis of symmetry, your roller coaster would start falling. Whee! And it would never stop falling. So as x gets bigger than 2, 3, 4, 5, 10, 1,000,000, 100,000,000, 10 jillion, I don't think that's a number. But as x gets bigger than 2, as you head towards the right, your roller coaster's falling. That's what decreasing means. Okay? Yes, Lewis?
So is the number always going to be second in the first part?
In increasing intervals and decreasing intervals, one of them will be a number, but will it always come first or always come second? No. And that's why I said you're going to have to use the graph to tell you that. So because this one is a downwards facing parabola, you're increasing to the left of axis of symmetry. So the number 2 got listed second. And you were decreasing after the axis of symmetry, so the number 2 gets listed first there. But if you go back to the first example, which was an upwards facing parabola, I was decreasing on the left, increasing on the right, which will change the position of the number. Yes, the number being written first or second depends on whether or not the graph is pointing up or pointing down. Yeah. Yes, Nick?
So it's pointing down on both sides, so what do you mean you're increasing?
Okay, so I know it points down on both sides, but that means you're talking about the y values when you say that. If you had to ride this roller coaster as you were, remember we read our graphs from left to right. So you start reading way back here, and you start reading this way, and you never stop reading that direction. As you are reading towards the right, your car is forced to go up. And it'll stop going up right here and start going down as you continue to read to the right. So you're always reading it to the left, from the left to the right, and you're describing if the car is rising or falling at certain x values. Imagine you were walking along the x-axis, and there's a roller coaster, like you're walking underneath the archway of the roller coaster, okay? You should be able to either look down at the roller coaster or look up at the roller coaster. One of the two, you're walking on the x-axis. And when you look down at the roller coaster or look up at the roller coaster, you should be able to see, is that roller coaster falling or is it rising? See, if you look up right here, let me switch colors. If you were standing right here and you looked up, you take a peekaboo up, that roller coaster is now falling, right? But if you were standing right here and you looked up, the roller coaster is still rising.
Yeah, I get it.
Yeah, yeah, I know. So it's a tough thing to think about. I know. So that's why I say imagine you're standing there, or imagine you're riding the roller coaster. Okay. Boink. So that was our intercept form example, and here is our vertex form. Yes, sir. Mm-hmm. The increasing or decreasing interval is the x values of where you stop rising and start falling, or vice versa. And the x value where you switch is always the x value of the vertex. So because the vertex is where the switch is going to happen. And since we're using x's to describe it, we always use the x of the vertex. The y of the vertex will always be the beginning or end of our range, always. The x of the vertex is the switch for increasing and decreasing. So this is vertex form, and we recognize it as vertex form because it has one set of parentheses that is squared. That idea okay? Okay. I see that this is a upwards facing parabola because the front number is positive. It looks like this. And just by drawing this quick little picture, I can see I have a minimum. I have a smallest value right here. And since this is vertex form, it hands us our vertex at what makes the inside equal 0, comma, the number to the far right, 4 comma, negative 3. Cool. Oh, well, the vertex is always in the dead middle, which means the axis of symmetry is also here at x equals 4. The next thing that this information is asking for is the y-intercept. Okay, well, let's do that. The y-intercept happens when you're on the y-axis, and when you're on the y-axis, you know x equals 0. So you have to figure out what the y-intercept is by plugging in 0. Okay. One half of negative 4 squared minus 3. PIMDAS tells me that I have to square that negative 4 first, which is 16. So it's negative 4 times negative 4. And half of 16 is 8. Our y-intercept is at y equals 5. That happens at 0, comma 5. That is right here. And what's great about every quadratic is that they are symmetric around the axis of symmetry. So if there is a blue dot 4 units to the left of right here, then there is a blue dot 4 units to the right of right there, like that, and you can just connect your dots. Notice this time, I did not ask you for the x-intercepts. Why? Because this is not intercept form. They're more difficult to find. In fact, they're not pretty. They're not whole numbers. They're ugly, scary decimals. Don't worry about it. Let's do domain, range, increasing, and decreasing now. Domain never changes. For quadratics, it is always negative infinity to positive infinity. Range. Because this graph has a minimum value, we write our interval from the minimum value that it hits, and by the way, these are y's, beginning at the minimum value of y equals -3 and going up forever. For increasing and decreasing, you always use x's to describe. And we know that the vertex, the axis of symmetry, is the switch. So the switch happens when x equals 4. So to the left of 4, is my car rising or falling? One person said falling, and that person's absolutely right. Decreasing to the left of 4. So negative infinity to the value 4, don't include 4. And to the right of x equals 4, my graph is going up. There you go. So regardless of whether or not we finish the notes before the bell rings, it doesn't matter. You can still do all of the homework because we've already practiced how to graph all 3 formats. Yes? Homework 15 is due tomorrow. Tonight's homework is due tomorrow. And the last example, the very last example, is the same kind of stuff. It's just done with standard form. Waiting for the active panel to catch up. There we go. Look, it's standard form. Eek, a decimal. It's okay. It's not a big deal. Yes, sir. Homework is due today, but tonight's homework is due tomorrow.
I just can't remember.
So again, there is nothing new going on here. You're going to do the same thing that we did for the last couple of days, and that's graph the equation. And after it's graphed, you just talk about min, max, increasing, decreasing, domain, and range. Absolutely nothing is new.